All right, now let's look at the second step. Each time we're taking away a portion of the chemical reaction. And this time what we've taken away are the addition of oxygens and hydrogens. And in an acidic solution, we're going to balance the oxygens with waters and the hydrogens with H pluses. But we first have to start balancing our electrons. So copper, pure copper is 0. This would be -2. That would leave the nitrogen as +5. So I have a -6. I need one of those negatives left over. So I got +5. An ion simply has an ionic charge as its oxidation state. That'd be -2 and +4. So let's first look at our copper. Our copper became less negative, and it lost 2 electrons. Our nitrogen is what changed in this case. So nitrogen became more negative, and it gained 1 electron. So that means that my nitrogen +5 was reduced, and my copper was oxidized. Now I have to exchange the same number of electrons. This one's a little easier than many. I just have to multiply this one by 2. So we have loss of 2 electrons and gain of 2 electrons. So this would be a 1 and a 2 and a 1 and a 2. Now at this point you should notice that we have on the left-hand side we have 2 times 3, so we have 6 oxygens on this side. And on the right-hand side, we have 4 oxygens. And to balance out the oxygens, we add water. So we need to add 2 waters on the right-hand side. Now, there's no rule that says that the waters go on the right and the H pluses on the left. You put it on the deficient side. So now I need to balance my hydrogens, so I would need 4 H plus, which is logical because it is an acidic solution. Now let's try the next one. Again, the first step is to assign oxidation states. So we have +6 and -2, -1 for our chloride, since it's an ion, so that's -1, +3, and 0. The chromium went from +6 to +3, so that's more negative. Now, because at least 2 of them, because of that 2 there, are reduced, I need to consider that in the electrons. So instead of 3 electrons, I'm going to consider that to be +6 electrons as our minimum that have to be exchanged. Now the chloride, we have the same kind of an issue. It became less negative and it lost electrons, and because we have a diatomic, it has to be at least 2. So I'm going to do 2 electrons for this one. Now to balance this, I would multiply this by 1, and I'm going to multiply this by 3. So I would have 6 chlorides, 3 chlorines, 1 dichromate, and 2 chromium ions. Now we have to take care of these oxygens. On the left-hand side, I have 7 oxygens. On the right-hand side, I have 0 oxygens. I'm putting OX so that it doesn't look like a 0 there. I know that's not the symbol for oxygen. And to balance 7 oxygens, I add 7 waters, which was going to require 14 H pluses to balance that. So that gives us the idea of how we're going to handle balancing with H pluses. Now, often we do redox in a basic solution. So let's take a look at the difference in the basic solutions of how we would balance those. Now again, that should be subscripted. Sorry about that. So that's a 0 and a -1. and this is a -2, which leaves a +5. Now, this is an interesting reaction because our only reactant is bromine. So that means at least one bromine becomes more negative. And I'm only going to do one of them. I know that would seem illogical based on our other reactions, but because I have a bromine here and a bromine there, that's going to take care of that too there. So it's going to be more negative. It's going to gain 1 electron. And it's also going to be oxidized. So that same amount is going to become less negative. In this case, I'm going to lose 5 electrons. We call this auto-oxidation. And it's a common one I've seen on predicting as well. So we'll work on that when we get to the predicting aspects of this. Now, I need to multiply this one by 5. So the reduction one would have to be multiplied by 5. The oxidation one is a 1. That leaves me with 6 bromines total, so I'll put a 3 in front of the Br2. Now, on the left-hand side, I have 0 oxygens. On the right-hand side, I have 3 oxygens. Now, in a basic solution, on the side that's deficient, whether it's the left or the right, it's the one that's deficient. Don't memorize left or right. I'm going to add twice as many hydroxides. So on this side, I'm deficient 3, so I'm going to add 6 hydroxides, which means I have to add 3 waters on my right-hand side. And now that should be balanced. You can always double check your charges to make sure you're balanced as well. I've got 6 negatives on my left-hand side, and 5 negatives plus 1 negative is 6 negatives on my right-hand side. Now let's try our last one here. That's a -2, so that's a +7. -2 plus 5. If you're having trouble with this, remember to come in and see me, and I can give you a little bit more individual help on oxidation numbers. You have the chart of the rules in your notes. So those are my oxidation number. Manganese is a strong oxidizing agent because it loves to be reduced. And since this is more negative, I'm going to give it 3 electrons. I'm going to gain 3 electrons. And it's the iodine element in iodate that goes to periodate, and it's less negative, and it lost 2 electrons. Now the lowest whole number ratio between 3 and 2 is 6. So I have to multiply the manganese half by 3 and the iodine half by, I did that backwards, by 2, and this one by 3. So I'll have a 2 and a 3 and a 2 and a 3. So I'll have, on this side I have 17 oxygens. On this side I have 16 oxygens. So I balance by adding double the amount of hydroxides that I need, and I would add 1 water. You can always double check your work by checking to make sure your charges are balanced in the end as well. So the next step will be